Capital H is used as a symbol of enthalpy. What is enthalpy? When a reaction takes place, the heat of a system will change. So the enthalpy is the amount of the energy or heat. The energy kept in the chemical bonds, including kinetic and potential energy. This energy involved in bonds breaking and bond forming. The amount of enthalpy is measured by using a calorimeter with unit joule. Enthalpy change is the difference between the enthalpy of products and the enthalpy of reactants. When enthalpy of product is greater than enthalpy of reactant, it contributes to an endothermic reaction and energy is absorbed by a chemical reaction. When enthalpy of reactant is greater than enthalpy of product, it contributes to an exothermic reaction and energy is released by a chemical reaction. The standard enthalpy change, written as delta H naught, is the enthalpy change for reaction that occurs at standard conditions. The standard conditions refer to temperature of 25 degrees Celsius, pressure of 1 atmosphere, and concentration of the solution is 1 molar. There are 6 types of enthalpy change that you should understand and describe it by using appropriate equation. Standard enthalpy of formation, written as delta H naught F subscript, is the heat change when 1 mole of a compound is formed from its elements in their most stable states under standard condition 25 degrees Celsius and 1 atmosphere. For example, enthalpy of formation of water is formed from its element hydrogen gas and oxygen gas. The value of enthalpy given is referring to formation of 1 mole H2O. Another example is formation of 1 mole ethene. Ethene is formed from its element carbon and hydrogen gas. The value of enthalpy given is referring to formation of 1 mole of ethene. Enthalpy of formation of oxygen gas and chlorine gas are 0. Oxygen and chlorine gas consist of elements already in the standard state, so there aren't any change here. Oxygen and chlorine are the elements at standard state exist as O2 and Cl2. The same value of enthalpy 0 for other gaseous elements such as hydrogen gas and nitrogen gas, as well as solid elements such as carbon in its graphite form. Standard enthalpy of combustion, written as delta H naught C subscript, is the heat released when 1 mole of compound is burned completely in excess oxygen under standard condition 25 degrees Celsius and 1 atmosphere. For example, when 1 mole of carbon is burned in excess oxygen to produce carbon dioxide, and this value of enthalpy is referring to combustion of 1 mole of carbon. Combustion of ethanol in excess oxygen will produce carbon dioxide and water. So, to balance the equation, let the compound of ethanol in 1 mole in order to parallel with the value of enthalpy given. Standard enthalpy of atomization, written as delta H naught A subscript, is the heat absorbed when 1 mole of gaseous atom is formed from its element in its standard states under standard condition 25 degrees Celsius and 1 atmosphere. This value of enthalpy is always positive because heat is absorbed and energy is required in bonds breaking. For example, to break the bonding of element of sodium in solid phase to form gaseous atom of sodium. The value of enthalpy is positive because heat is absorbed in bonds breaking. Another example is to form gaseous atom of chlorine from chlorine gas. So, in writing the equation, let the gaseous atom of chlorine in 1 mole in order to parallel with the value of enthalpy given.
The atomization of metals involves the changing of a solid metal into free metal atoms in the gas phase. It is an endothermic process, since energy is required to break the strong bonding existing in a crystal of metal. Notice that the atomization of a metal is equivalent to the direct transformation of a solid into a gas, that is, sublimation. Therefore, the enthalpy of atomization for metals equals the enthalpy of sublimation.
Standard enthalpy of neutralization, written as delta H naught and subscript, is the heat released when 1 mole of water is formed from the neutralization of acid and base under standard condition 25 degrees Celsius and 1 atmosphere. For example, 1 mole of water is formed from the neutralization of hydrochloric acid and base of sodium hydroxide. The value of enthalpy given is referring to formation of 1 mole of water.
Neutralization reaction between acid and alkali is an exothermic reaction because the heat that is released causes the reaction temperature to increase. 1 mole of dilute hydrochloric acid reacts with 1 mole of sodium hydroxide to release 57 kilojoules of heat. Therefore, the heat of neutralization between hydrochloric acid and sodium hydroxide is minus 57 kilojoule per mole.
Standard enthalpy of hydration, written as delta H naught hyd, is the heat change when 1 mole of gaseous ion hydrated in water under standard condition 25 degrees Celsius and 1 atmosphere. For example, 1 mole of sodium gaseous ion is hydrated in water, becomes sodium ion in aqueous phase.
During the dissolving of an ionic compound in water, once an ion is released from the crystal lattice, it is immediately hydrated by a number of water molecules. In this process, some of the hydrogen bonds between molecules of water are broken and replaced by much stronger iron-water interactions. The amount of energy required to break water-water hydrogen bonds is far more than compensated for by the energy released by the interaction of ions with water molecules. So, the hydration process is always exothermic. Enthalpy of hydration is a measure of the attractive forces between an ion and its surrounding water molecules. It is defined as the standard enthalpy change when 1 mole of gaseous ions is transferred into a solution and hydrated.
Standard enthalpy of solution, written as delta H naught solution subscript, is the heat change when 1 mole of compound is completely dissolved in water to form a very dilute solution under standard condition 25 degrees Celsius and 1 atmosphere. For example, when 1 mole of compound of potassium chloride is dissolved in water, potassium and chloride ions are formed in aqueous phase. In writing thermochemical equation, the value of enthalpy is always written at right-hand side with its sign. The enthalpy is an extensive property, whereas the magnitude of delta H depends on the amounts of reactants consumed. For example, when 1 mole of methane is combusted, will release this amount of energy. If it involves 2 moles of methane, so the magnitude of enthalpy will be multiplied 2. If the reaction is to be reversed, the magnitude of enthalpy is in opposite sign. The enthalpy change of a reaction depends on the states of reactants and products. For example, ice required more energy to form water vapor compared to water in liquid form to form water vapor. For a certain equation, can have same equation with the same value of enthalpy but called as different type of enthalpy. For example, enthalpy of formation of carbon dioxide can have same equation as enthalpy of combustion of carbon. Another example is enthalpy of formation of iron trioxide can have same equation as combustion of iron but with half ratio of its stoichiometry and its value of enthalpy.